Alrighty. Good afternoon, everyone. It is time. We have a packed agenda. So welcome to the Trusted Execution Environment and Provisioning. And for the first time in a while, you have both of the chairs here present and live. So thank you, Tiru.
Hello, everyone.
So Tiru, my colleague, myself, Nancy Kiamwinjit. Again, you are attending the TEEP working group. By now, you should be well aware of the Note Well, which speaks to the intellectual property and the IETF processes. I will let you read the slide in the interest of time. Meeting tips, the only thing I'll call out, but I think everybody here is following protocol. For those in person, please make sure that you are wearing your masks. Keep your audio and video off. We are running questions through the online Meet Echo queue. So for those in person, to respect those who are remote, please get on the queue before coming up to the mic. Okay. Code of conduct. I think we're a pretty chill group. So again, just keep the discussions professional. Okay, so I think we've already gone through this. Thank you, Peter and Chris, for being volunteered to take notes. Very much appreciated. So agenda bash, and we'll apologize to the presenters. We had only requested 90 minutes, as that was all that was needed in the past. So, while you all do get to present, we had to cut your times a little bit short just to accommodate everybody who's presenting. So as you can see, we have a fairly packed agenda. We cannot take any new items for presentations, but hopefully this is a time to bash. The order and the time, is that okay? Going once, going twice. Okay, so with that, we can go ahead and get started. And we'll have Ming. I presume you want me to share the slide?
Yes, hi, Nancy. Yeah.
Alrighty, you're set.
Yep. Yeah, thanks. Next slide. Quick summary here is a last item. So we have a draft update from draft version 18 to 19, and this was has been in last call for several sessions, right? For last several IETFs, and then for this update, I would say there are multiple reviewers' comments. I try to address. We have addressed all the comments, and we received many feedback. One of the things here I need to mention is I didn't know some of the comments because they were not in a TEEP email thread that was tracking. And I found out from the teamwork group page. I found several comments. You can see the from AD from a security directory from Ben Schwartz and from Paul. They gave comments over old version 16, but still a lot applies. So we took those comments and all replied. So they have, and then we have Bob Hollis and Anis comments over version 18. We also have comments from Roman and Robert Walton. So totally about 7 people's comments, and this adds up. There's quite some comments. There's a main ones I would say highlight. It's one is a security review because it got 2 from security review that was from old version, but there's some still some, and we find still applicable, and we made some updates. Majority of them are minor updates. So we go with some of them. So I have about 18 slides next. We'll try to run fast in 20 minutes, and we'll see mostly the main ones we talk. Yeah, the next one. So this one from Ben's comments is from old version 16. They make question about the naming terminology about trusted application. They call it trusted application TA. Right? We use TA everywhere, and his suggestion we should call it trusted component. And the second one is about the question he has about called trusted. It doesn't look right adjective. It may be isolated. So this is an old one. Then we had some email conversation and also a discussion on the first one about called trust application and TA. In the document, we said um, three things. First one is protocol spec already using trusted component. And the second one is the TA, the definition architect doc. Our definition covers it. We already said it's trust application may means a application or in some application, application component. So we already specify that. Third one is that TA is also common industrial terminology, industrial term. What change we add is we add the reference in the spec. So when we said application component running inside TE referred to, for example, a global platform or open source TE, they are all called TA and as a trust application. So we still keep it that way, and but with definition, we covers both. So that's about the terminology aspect. With regard to word trusted application versus isolated application or isolated component, we discussion goes that one is still right modifier to say it because you trust the um, components at the time it installs, right? Still trusted. Um, so that's for this one. Any questions or just move to next slide? All right. Then a few there's minor clarification questions. Maybe you got in this area. And first one, being asked for some clarification, maybe some discussion about what the device owner can do. But I would say this one is was the old version 16. In 17, 18 later, actually we added definition about device administrator for a while. And in the device administrator, which is clearly specifies what the privileges or roles a device administrator has and the owner has, right? And we specify already that the decision maker is device administrator. And secondly, trust applications installation delegate to the TAM, right? TAM has a privilege to install on behalf of the administrator. So that I've clarified. Then Bing has several suggestions about the word change. For example, here, the right of verified rights of developers word change from rights is to permissions. Feel rights is too broad, right? It's a kind of a loaded term. Next one have some incomplete sentence. It's that um, the installation talk about tier installations as it's needed so that untrusted app can continue. So it's instead should say installation of untrusted app can continue, right? Can complete. Then there's a one sentence where it's considered confidential. Then it didn't specify by whom and from who. That he said add some more information. So we took a suggestion and make a modification in below the number 4. We said, for example, by whom, right? For example, when developer who want to provide TA without revealing its code to others, as a case. He then, by the way, I would say this Comment below. I don't go through by person. I go through sections, section 1 to section 9. So section 1, there's also comment from a Roman about the wording. Says danger of attacks or the consequent attacks, and we change the word from danger to risk of attacks. Just some of that terminology change there, so making them more readable or acceptable. Next slide. So now we do section 3. Section 2 doesn't have much of a comment. Section 3, sorry for the formats, section 3 is a use case examples. This one is being asked, say, for trusted user interface. And the question is anything, example in a mobile device. It's a talk about mobile device. You have trusted peripheral that is not accessible from the trusted node from normal OS. It looks like it's a theoretical. There's no example. And then David here, David Thaler has comments that. So we know for point of sale devices, payment devices, then it's extensively used that need a trusted UI, right? With type pin and so on. So the changes, we expanded description, says trusted user interface may be used in mobile device or point of sale device. We added a point of sale device there. So for that, because this is a payment use case anyway, so we should add that. So that was added. Next, please. IoT use case, again, about examples, several classifications actually. One is Ben commented what kind of, give example, right, which is IoT devices that cannot allow IEOS to run certain actuators. And Ines Robles asked as a different one, says, what kind of IoT devices fit to run the TEEP protocol that way? So what's capable? He was suggesting whether we can specify particular classes, for example, use IFC7228. And more author discussion was there for Ines one, what classes of IoT device was say that IFC7228 don't really define the capacities about what will fit the protocol. What it says in general, we don't specify it. We just leave that to adopters, right? They can decide, they could check, the code, right? Is the code capacity code resource need that T device will capacity fits for that one. With regard to example being asked, there's multiple discussion from Dave, and he has demoed some devices which can provide that. Brandon also has replies in a mailing list. So what we end up is, as a update in the draft, we added the global platform TE as a reference. And we added that example as it was sitting in a paragraph. I can read here. For example, global platform TE use the term trusted peripheral to refer to such things, which can be accessible only from TE, and the concept is used in some global platform devices too. So that's answer to these comments. And next slide. This is the most of the controversial, I would say most of the important one in this update. Ben, as part of security review, he said, well, we manage the trust anchors, especially trust, right? What, and device can trust TAM. What if a TAM is a hostile TAM, right? Then Brandon also has comments from last IETF. But the threat description we already have in section 9.5 talk about a compromised TAM. Right, earlier it was a pretty brief one line. So we felt that we need to add more about potential mitigations, what administrator, what a system can do to mitigate this, right, as a part of a threat. So there'll be long revision here, as I quoted here. It's pretty long. I guess I don't need to read them through. Um, the first line is the original one. Then remaining we added more for say potential candidates, right? Few ideas to mitigate threats. What a tip agent and device owner or dimension can do. So what we added largely below is that to mitigate the threat, tip agents and device owners have several options, included, but not limited to this. We have just a few candidates because we cannot exhaust the list, also implementation specific. But overall, so you can apply the echo, right, to the time key. So in device side, so they can limit the threat or damage from compromised time, right? Echo can control that. Um, or use a transparent lock. That's more for compromised time, right? And transparent lock can um, expose um, what the TS are using and versus what time publish, what they, well, legitimate time, they will publish what they will support. If you compromise, then if a TS not in the list, you discover that there's a mismatch. This case is a compromise case, uh, time case. Also, could use a method, for example, remote attestation of time, right? Reverse other side. So today we have remote attestation of device to time. Now you can do time to device as well, and other ways. There are other ways which we you just listed several. We feel it's possible and likely feasible. Regarding hostile time, that where a time provider intentionally abuse the devices, right? Abuse the device, not compromised in certain way by hacker. But we consider this. We have multiple discussions with within the authors, also like Brandon. So we felt that predictive, right? We felt this a hostile time is equivalent to a compromised time. It's a special case of a compromised time. In this case, the people and team, the executives in the times or management is compromised, right? So, so we consider it's equivalent, and we use it one. This is same category, compromise time threat to cover both. Any questions? Next slide now. Um, this one's more like a minor updates. We already was said to trust validation. We check a trust anchor at sub to CA and so on. So there was then Bob Holly, I commented that one. That there's an additional constraint. We're talking trust anchor, so we just added that here as well. Make it explicitly. We added that bolded font in last sentence. We say we will validate chain up to authorized trust anchor in device and conforms with all constraints defining trust anchor, right? So it's a part of validation. We'll also validate the constraint just to make it complete explicit. I think this is just straightforward. Next slide, please. This one's about the clarification for the who contacted who first. This was from Bob Hanley comment. We said TAM cannot contact TIP device, right? TAM cannot contact the TIP agent, right? For the firewall for various reasons, was usually the TIP broker will initiate that contact on behalf of device TIP agent talk with TAM. And the questions says that whether TIP agent must ask the broker to initiate TAM or broker can initiate only when to trigger that, right? We can trigger that. So we revised this paragraph. As it's largely David made a change. Dave, do you want to say, you want to talk this one, or I can read here?
He says he's good.
I've just read that, so I guess you need to go to speak otherwise. Okay. So we just says um, explain a little more. We say this is a protocol architecture is particularly highlighted. The architecture in Figure 1 accommodates this case well as other less strict restrict case by leaving details of this protocol appropriate type to the type transport protocol. For example, one defined that David spec, right, type over the HTTP. That's the main one, and we did describe to explicitly says that tip agent um, runs when it is running in a user devices, enterprise devices. Right? Firewalls will normally don't allow external access to it, so then we usually we need a kind of a tip broker to initiate, right, to initiate that contact on behalf of tip agent. So that's I don't need to read the little word by word. Um, so this is just for clarification. There's no difference, major material change, I would say. Next slide, please. This one is also it's an editorial change. Thanks to Bob Hawley, it noticed that notations at an early. I didn't put the early one. Early one we called app dash one, app dash two, TA without dash, TA one, TA two without dash. He said, well, let's make it consistent. Everywhere use the same format, right? App, we already called it untrusted app. Let's call it UA, right? So then everywhere use dash, time dash one, time dash two. So this is the current one. We I made minor changes. Everything just uses that format: TA dash, UA dash, time dash, and one two. So that's the update. No material change, just a simple notation change. Next slide, please. This one I do need a call out. Ben commented on the use of a must. In multiple places we say, for example, the implementation must support encryption. Then the algorithm must support integrity protection. That must we use lowercase. Yeah, lowercase. I highlighted for here. We in architecture document we do not use uppercase must, right? That's some spec or some. Well, we do use in some spec too, but for the architecture document we choose not intentionally. There's a David have this uh, comments, very last line we quoted here. Um, some part of IETF, which is some people will have some feedback, so they don't always like to use that uppercase. And so we took that feedback, so we choose to use just a normal word, regular case. So that explains. I think that's the main one. The others are just editorial change. I would just let's skip this one. Let's continue. Next slide, please. Clarify support encryption purpose. That this is from Roman. Roman comment. Support encryption. His question was encryption for data at rest or data in motion. We make it explicit. We add one says this encryption purpose is to used to ensure that no personal data is sent in clear. It's a data in motion protection. Next slide, please. Section 4.5 is good catch by two people. Paul and Robert Wilton both said this sequence is not read right. And I recognize that a good catch here. You see, we adjusted it. It really says when the installation normal app happens. It felt after the normal app, I would say play word, right? Untrusted app in App Store, use download, right? Use it once it's supplied, and then user will download from there. Then that trusted application usually happens that one after normal app installed. It may come with a long ways together, maybe bundled, but the step is just yet after normal app happens, then start to install the trusted application. So that in step one, we have A and B two step. We just make it after A, then a user can already download the app and install. And at that time, if you need TA is already supplied to tab, right? So that timeline here, just to make it install a sequence this way, it'd be more natural than the origin diagram. So you can see difference really step 1, 3, 4 here. That 2A, 2B it's a 3 is in the middle of a 2A and a 2B. So that's the change. Instead of the 3 must happen after B. It's about right, but this one is also maybe more natural. Next slide. This have a major change. The current paragraph says in section 6.1 about role of TEEP brokers. The first line says a TEEP broker abstracts the message exchange. Abstract message exchange. Ben and Roman both commented, well, it's a Roman is a forward Ben's email. What does means broker abstract? What does abstract mean? So we David reread to this paragraph. So we just remove word abstract to explain it in plain language. So we just say TEEP broker interacts. Now, so just what abstract means. That's really explain. Interacts with TEEP agent inside TE, and the job is relaying message between TEEP agent and tab. The remaining follows. I would say there's no material changes. Some way more, little more explanations and what the abstract means. It's really just a defined flow and it's a role. Next slide, please.
Hey, Ming, you're running over, so we'll give you one more
Okay.
minute if you can wrap up.
Okay.
Can you focus on the slides which are quite important and skip the ones which you think we can review it offline, right? Can you focus on the slides which you think the working group needs to hear right now? Skip to the slide which you think is a very critical comment.
Hello, someone speak.
I was saying, can you move to the slides which you think are quite critical?
Yes. Can you just roll? I'll obviously next slide.
Yeah.
Just roll it. Next slide. Next slide, because those are all the again share sliding. Next slide, because all these are just minor update. So class, okay, just a class of devices. We add a reference to one means a class of devices refer to it in attestation. Next slide. I want to go to the next slide. The next slide. Yeah, this one's already covered. This one, I just said we made an update inclusive language. This is from multiple people, but from Lars and Roman. And we changed man in the middle to manipulate in the middle. Okay, so I just said that one is maybe a little bit new terminology and a new, but David look up in some different specs. It looks a manipulator in the middle is a well accepted one. Retain the same acronym of MITM, right? So still start with M. That's about it. Yeah. Next slide about needs, I think we'll skip it. So you can go to next slide, but it's all. Yeah. These are minor, so it's just for reference purpose. That's all I have. Thank you.
Okay, thanks, Ming.
Yeah.
Go ahead, Brendan.
I just had a quick comment on that last one. The most common terminology I've seen has been on-path attacker.
Okay.
Okay. Yes. Yes. So this is Akira Tsukamoto, and I'm going to talk about the hackathon. And next page, please. Yeah, it takes time. And I'm going to talk the TEEP and SUIT and COSA and RADS hackathon. Unfortunately, I only wrote something I was able to pick up, and many of the early pages is more about the clarification we had to talk in during the hackathon. Yes, next page, please. And yeah, these are pictures, and we're running out of time, so next page, please. Yes, yes, I had some of the points planned for the hackathon, and we're going through of them from the next slides. Yeah, next page, please. Yes. Yes. This was something we did talk at the IETF 114, and heavily after the 114, we wanted to have a way whether TAM have to read contents of the attestation payload without opening or verifying the signature. And we have to revisit this again for this hackathon, and this is the detail of the conclusion. So we do not have to revisit again. So the TAM will read attestation payload format, and then if the matches with the attestation result string described in the slide, then TAM will have interest in going to open it and process it. Other than that, we'll pass the contents of the attestation payload to the verifier. Yes. Next page, please. There's a hand.
Go ahead, Mohammed. Mohammed, you're in the queue.
Yeah, so do you hear me?
Yes.
Okay, so what exactly do you mean by, if you go back to last slide, please, what exactly do you mean by payload? It's an undefined term. I don't see it anywhere. Does it mean in the context of TSCX, does it mean, let's say, the quote, or does it mean the report, or what exactly does it mean?
Could you go back to the previous slide? Yes. It's a B string, so it's a binary. It depends on the implementation, if it's OPT or SGX or yes. Yes.
Yeah, for SGX, what exactly would it mean?
Excuse me?
So for SGX, software guard extensions by Intel, what exactly would it mean?
Yes.
Does it mean the report or the quote, or
Hold
what
on,
exactly
Mohammed.
does it?
Dave is coming up to the mic to help.
Sure,
This
sure.
is Dave Taylor. The word payload just by itself just means in the middle of the slide there, you see the two lines with a question mark in front of them. It's the name of the field in the TEEP message. That doesn't answer Mohammed's question, but that's what the first question was, what does payload mean? Okay, and so there's two fields, right? There's the payload that's a byte string, a byte blob, and then there's a text. It's a format that tells you what the format of that byte blob is. So the second question is, well, what if you're using SGX? Okay, if you're using SGX, this document doesn't tell you the answer to that, but what it does say is that if you were using, say, an SGX quote, then you would define a text value for attestation payload format that says this is an SGX quote, and then you'd put the quote into the beaster. This document doesn't tell you what the text values are and the beaster values are. It provides a way for people to register them. And so if you are using SGX, you could do that and then use these two values where text would be, SGX quote or whatever the registered value is, and then you put the quote into the beaster field in the attestation payload.
Hi, this is Hannes. I wonder whether we should use this newly sort of published draft in the RATS working group on the message wrapper, which allows you to kind of do exactly what is described on the slide, to wrap these RATS conceptual messages, which evidence and attestation result certainly are. So maybe worthwhile to look at that. I will send it just occurred to me now as you are presenting it. It missed it previously, which was, for what it's worth, also discussed with Ned and in the context of SGX in the CCC.
Yeah. And yes, after the hackathon yesterday and the day before yesterday, we talked with Ken and Isobe-san, and probably the implementer of the TAM will be reading the payload format, whether TAM is interested for the opening signature of the payload or not. Probably is the right way of the interpretation of this issue. Yes. Okay. And next page, please. Yes. Yeah. I mean, I need to go forward. So this is originate for a very long time from IETF 105, and it's about how Miyazawa-san is started the implementation of the background check model. So what will happen in the combination of passport model, and we did discuss in the IETF 114 that if we have a passport background check model and passport model combination implementation in the TEEP, then we had to add another message to send the attestation result to the relying party. Then we decided to put it in the update message, and we did add format for putting the payload in that update message, but we didn't really talk about in the draft. So yeah, this is the explanation again, and we might Isobe-san or somebody else might have add a little bit of description in the draft later with the pull request. Okay, and next page, please. Yes. Yeah, this is also something we've been talking between the 114 and 115. We decided not to use CBORD tag on the TEEP message, but how about the suit envelope? Initially, the draft was using tagged suit envelope, and the conclusion is not to use a suit envelope. And yes. Yeah, okay. Let's go to the next page. And this is what Dave was doing in his implementation. So at the last IETF, we decided to have will be mandatory authentication algorithm we're going to use. And ES256 and EDDSA was decided, and we just and that was a little bit related with the query request needed to have multiple signature on it. And we decided to use COSES sign, which supports multiple signature, instead of COSES sign 1, which only have one signature on it. And yes, and then we need to and many of the people is relying on the Lawrence T-Cose implementation, and yes, we're just going to proceed supporting it. Next page, please. And this is fixing CDDL syntax error, which I was talking a little bit in 104, and we did finally fix it. It took me about 3 days, and had to talk with the Brandon and many people and Carson and to tackle it, and also I wrote the description how to go through to check the TEEP protocol CDDL syntax check on the README. So probably it's okay now, but however, it does depends on the suit message need to be also require CDDL syntax error. So probably in the future we will go split the makefile command, just going through the syntax check on the TEEP message itself, or only with the suit related message. Yes, next page, please. Yes. Yes. This is go back for me. It's more going back from OTRP age when the TEEP was using. It had a feature to delete the trusted component, and we decided to have a way to delete with the using suit manifest for the trusted component. Then how to specify the target of the trusted component, what kind of ID we'll use. And the suit digest, the benefit of the suit digest is it's a hash value inside. So if it's any of the value is changes with in the binary, and then it's easy to spot it. But yes, at the conclusion, we're going to use suit component identifier. Okay, and the next page, please. And there's many implementation were going on the table. So Miyaza-san attended the IETF for the first time. So he was implementing passport model on the TEEP protocol, which is very beneficial. My implementation not doing that, and any other people. So, and yes, and it has 4 sequences. He didn't seem like finish all the 4th sequence, but it's making a progress for making the draft complete. And Ken is yes, he was he was, I think it was yesterday or the day before yesterday, he made a huge among us a lot of pull requests. Yes, and yeah. Yes, and Isobe-san was yes adding remote attestation and was also clarifying many of the feature of on the TEEP combination with RAT's activity. Yes, and yeah, the summary implementation, many of the implementations link is here, and the solved topics. It's not only these because it's only something I was able to pick up, and so far I was known by watching the GitHub is 5 pull requests and updating the draft. And also new issue was filed like 3. I think it's 4 now. And this and next page there's 2 more additional page for the who wants to go through by yourself. The next page is probably all the links. Yes. Any question, please?
That was actually great progress. That's good.
Thank you.
All right. A couple of these slides will overlap with Akira's, so we'll try to go through those extra fast and leave the time for the other ones here. All right, so TEEP protocol, a bunch of co-authors. Next slide. All right, so there's 3 sections: general things, things specific to suit, and things specific to RATs. So here's the first section, which is the shortest one: general TEEP protocol issues. All right. So there was a discussion in the past, or an issue was which TEEP messages are protected with which cipher suites. Okay, and so after the first exchange, it's really easy because once you've done negotiation, you use the negotiated one, right? But how do you do the negotiation? That's where this one comes up. Okay, we do specify that the same cipher suite is used in both directions. Okay, so the one that you're using for signing is the one that you're using for checking and so on. We don't preclude if you ever needed to be different in the 2 directions, that an extension could do that. Okay, but we didn't see a need to do that now in the base spec. As Akira mentioned, the query request, which is the very first request, right? Since you don't know what the other side has, then you need to try both. So the TAM must support both algorithms, both ES256 and EDGSA, and the device gets to pick one. Okay, it can choose either one of them, but it has to do one of those 2. Okay, so the first message that comes from the TAM has to try both because it doesn't necessarily know what the device has. And so this is where it switched to say COSE sign which allows you to sign the same message with both algorithms. Okay. There was 4 other alternatives that were considered and discussed, but that was the one that out of the people that were commenting on it before, multiple people liked that one the best. And so that's the one we put into the spec and then started implementing. And the only implementation issue we saw, as Kira mentioned, was that TCOSE doesn't yet support the ability to do EDDSA with COSE sign. It only has ES256 and so on. So but that will be coming. We said we're not going to change the spec waiting for a single implementation where the implementation's in progress. So we'll just do that and encourage implementations. Okay. And also clarify, this is a little ambiguous before, that the first response from the device itself uses the same mechanism as later messages. Before, the spec was ambiguous as to is it actually signed or not, and now it says it is. So the only weird corner case is if for some reason the TAM sends a message and doesn't put the mandatory ones in its list of signatures, then of course the device is going to say, well, I don't support either of those. I support the mandatory one. And so we allow this case that says, if you end up having to send an error unsupported cipher suites, which would typically only happen if the TAM supports the mandatory ones, but then it really wants to upgrade to a much later one, right? The third one, the new and fancy thing. And it says, I only support that one. Can you support that one? And it says, no, I support this one. And so that's for that corner case. It's not disallowed, so it's just there. Okay, next. Okay. Unrecognized TEEP messages. Okay, so let's say you have something that sends a TEEP message, but the message number isn't one of the regular 6: query request, query response, update, error, success. What if it's an other random number? What do you do? Okay, or anything else that violates the spec. What do you do if you violate the spec? Well, there's an IEB document that argues that anything that says you just drop invalid messages, that's actually harmful because it lets the bugs propagate and stay in the wild. And instead, you should really reply with an error so to put the pressure on the people that are doing their own thing, or the implementation is doing their own thing. And so 2 sides. The first part is what happens when a TEEP agent includes an illegal message, receives an illegal message from a TAM. Well, we've got an error message. So we just change it to say you said an error in that case. Okay, so that's what the device does if the TAMS has something that's like a bug. Okay. Next slide. So what do you do if the TEEP agent sends something that's bad? So what does the TAM do, right? Because the TAM, everything is initiated from the TAM and then responded to by the agent, right? And so the TAM doesn't have I'm going to send you an error, right? It can send a query request or an update, but that's pretty much it. And so previously it said it just drops the message if it's not valid, and you can't send an error message. But the TAM can actually update software. So if there's a bug in the TEEP agent, the TAM can fix that by setting a fixed version, right? And so what the document says now, or the proposed text to add, because this is not fixed in the last one that's posted. This text is, I think, in the GitHub repository pull request. It says it may also do additional implementation specific actions, such as logging the results, like if you don't yet have a newer version to install, or attempting to update the TEEP agent to a version that does not send invalid messages. Okay, so you might log it and says, please get a new implementation or whatever. Or if you've got one, then you initiate the update to go and fix the thing right now to stop sending you the bad messages. Okay, so that's that issue. All right, there's a bunch of editorial things that I'm not going to go through here because I believe the person that brought them up, so Michael Richardson, Thomas Vasati, and so on, I think have already acted all the responses and they tend to be editorial. So if you want to talk about one of those, ask me at the end. Otherwise, I'm going to go on. All right, so let's talk about things that are specific to suit, okay? And so now I'm going to go through a couple of issues about the relationship to suit.
Hey, Dave.
Yes.
Do you want to take questions or somebody in the
Yes,
queue?
please, Mike.
Hello, Mike here. Just want to say TCOSE does support EDDSA since September.
EDDSA, yes. And in fact, during the hackathon, I was actually using EDDSA.
Oh, I see.
But I can't use it with COSE sign. And so,
oh, not you mean
yeah, COSE
sign
sign is currently only in the dev branch, and EDDSA is currently only in the main branch.
Oh,
there
yes.
actually exists no branch that you can use EDDSA with COSE sign.
All good. Yes, I know that he was going to add EDDSA soon.
So yeah,
okay.
We actually did get I did get EDDSA working during the hackathon. I just couldn't use it with the query request message. All the other messages after that, EDDSA was working great. I actually did, that was one of my main tasks on Saturday, was to get EDDSA working with all the other messages and my test passing, and they all worked great. So thank you for the EDDSA support in TCOSE. All right, use of suit. Next slide. Okay. So for those of you that were in the suit meeting an hour and a half ago, Brendan actually talked about this one. And so this is the more details as to where it came from. So in TEEP, you want to be able to uninstall things that were previously installed. So I've got some trusted applications that I want to uninstall. And so the unneeded manifest list is what does that. And whether it's a suit digest or not, Akira mentioned this, I'll come to this on the later slides, so ignore that for the point, but you can specify, here's some manifests to clean up, okay? And so this works as long as the installation manifest already includes the unlinked directives, right? Otherwise, you have to go off and get a newer version of the manifest that has the unlinked directives, okay? And so what if that hasn't happened yet? Or do you pre-cache it? So there's all these weird things. It says, what if I don't have a newer version? I can't create it myself because that was created by the software developer that created that manifest, maybe, okay? And so although there could be ways to do it, this is the most natural way to do it, is to say, to encourage the manifest to install stuff to also have the uninstall commands, so that I can just reference that same manifest and say, that manifest that you installed before, just go and follow the unlinked directives and clean it up because you've already got it, okay? This also solves the local admin case that says, okay, I put something down on a particular machine, and then now not with the TEEP protocol, but if an admin walks up to the machine, let's say he can get to a command line, or some other variation of remote, remote login, and then you can initiate a local uninstall without using the TEEP protocol because the manifest is already there, right? So it tends to be most useful there. And so we put this into suit trust domains, and that's what Brendan presented in the suit working group earlier. Okay, so this just says this takes a dependency on that. And this is in draft 11. So next slide. Is there any questions? Okay, Akira mentioned this one. We stuck with the suit envelope untagged. I'm not going to go through this one because Akira already did, unless there's questions. But the one question that's don't go on to the next slide because there's a follow-up question on here, which is as part of that, it came up to say, well, the only case that you might want, the thought was the only case you might want to tag there is, what if you had other CBOR-based manifest formats you ever wanted to allow in the future? Okay, and you want to do that without waiting for an extension and still use the manifest list, reuse the manifest list. And the discussion was to not do that because you can always do it in an extension. But if you're going to eventually allow other manifest formats, then you might want to do things that aren't just CBOR. So for example, if you wanted to be able to pass an MSI or APK or something like that as your manifest, right? And then you'd want something that wasn't CBOR based, and so you would need something else anyway. Okay. And so the suit envelope tag doesn't help you with those, right? And so we said that's why we're not using suit manifest tagged. And so for other manifest formats, we'll leave that to an extension. And then that could allow you to use other manifest formats if you wanted to use it with, APKs, MSIs, whatever else. So, but not in the base document. Okay, so next. So that's the proposal here. If anybody has an immediate demand, speak up, but that's the resolution right now, is to say the things that people need right now is in the base spec, anything else is in the extension document. By the way, suit took the same approach with the suit manifest. So that, okay. All right, the suit digest. Okay, so I said I was going to come back to this one. Suit digest or suit component identifier is what we ended up. Akira did mention this. And the more details there is that we ran into in the hackathon was the suit digest. If you have a case, say a device with multiple TEEs, okay, so let's say you have a TEE in a network interface card or something like that, and you got 2 cards, or you have 2 different processors, or you have 2 different areas in the same processor, and you want to take the same component and install it in multiple places. Like I want it in this line card and in that line card. You can't do that by just saying delete the one with this manifest, that manifest hash. Okay, because it's in multiple places, right? So you need the more granularity, and that's what the suit component identifier gives you. Is it's a path that says which place it is, and so now you can be more granular and say I want to delete the one in this location instead of just the one with this hash, which is not necessarily just one. Okay, so that's why we did that. And so during the hackathon, this is not in the draft yet. This is one of the things we ran into an implementation, and so everybody around the table that had implementations there. We kind of brought this up, and unless there's any objections, then this is what would appear in the next version of the document to address that. Okay. And then the last part here is deletion by a component identifier requires that you have a component identifier for every manifest. And this brought up the discussion that in suit, we only had component IDs, and Brennan mentioned this in the suit meeting. We only had component IDs when you are a manifest that depends on another manifest, and the other one has a component ID, but the root one doesn't, which is fine if you're a constrained device, but if you're a device with a bunch of trusted applications installed, every trusted application is its own root manifest, and there was no component identifier for that. Okay. And so that's what Brennan proposed that we added into trust domains. For this case, it was, I think the word oversight came up not by intent. And so this is what motivated the discussion that Brennan had in the suit working group before. So again, another case where the TEEP protocol actually requires this in order to install and uninstall multiple trusted applications. Okay. All right. This one we also did mention briefly, and you'll notice my slide that I already had prepared points out what somebody else said at the mic and the suit manifest and the suit working group. So the TEEP protocol does not do encryption at the message layer. Okay, it does encryption at the payload layer. So for example, you can pass an encrypted payload in a unencrypted TEEP message. Okay, it only does signing. And so the current TEEP protocol spec says nothing about the privacy of suit reports. And by the way, neither does suit reports today. And so that means that we don't actually say anything, and we need to say something someplace. And so TEEP isn't the only place suit reports are likely to be used. Somebody else made this point in the suit working group meeting. And so this says, since suit reports can be used in other mechanisms, then suit reports is the right place to specify how to encrypt and protect suit reports. Okay. And so the proposal is to mention it in security considerations and point to the suit reports for the actual details. Okay. And I see maybe some head shaking. If you think that that's not right, come to, if I said it wrong, Russ or Brennan, come and weigh in. So
I'll forgive that you're not in the queue.
That's not what I heard.
Okay, then please summarize. Okay, suit working group chair at the mic.
So what I heard was, gee, there's lots of places where we want these plain, and that when they're put inside, for example, an EAT, it'll be the EAT profile that specifies how to encrypt it, but the security considerations need to say what aspects such a wrapper needs, is what I heard.
Okay, then let's have that discussion now, since we kind of deferred people here. If you are storing it in a file for transmission via SneakerNet, whose job is it to do that? I would say whoever writes it to a file, you need a file format, and so that's why you might need to say an arbitrary way of saying a suit report can be encrypted.
Right, I think that's probably the case.
And that's my argument for why it should be in the suit reports document.
Okay, Brendan.
I mean, that's why it's Brendan's job and not mine.
To clarify, you're asking for a security consideration in the suit reports document that says, if there's sensitive information in here, you should probably encrypt it.
At
I'm
minimum,
just making sure I understand what you're asking for, because that's what it sounds like to me.
that would be minimum. I think there's an interesting question, which I do not know the answer to right now, which is, does it make sense to say more details about that in terms of, so let's reference your MTI document. If
Yeah.
you're going to encrypt it, whose job is to decide constraints on the algorithm? Should you say, you should encrypt it with one of the things in the MTI document?
So from a practical perspective, and remembering that that MTI document is explicitly for constrained node firmware update and no other uses of suit.
Yeah.
That it's already taken care of because your device only has that algorithm anyway.
Fair, yep. So do I take it as your view is that suit report should say that you should do it, but not specify algorithm details and leave that to whatever the container is, whether it's a EAT profile or somebody doing a file or whatever else gets to decide that?
Yeah, because I don't think it makes sense for me to specify in suit report, for example, that you should put it in a zip file and make sure there's a password on it.
Okay.
Right? That doesn't make sense, but maybe there's a use case where you need to do that.
Okay, so if you're going to cozy wrap it in an encrypted thing, that wouldn't be in the suit document.
Right, and because that would preclude you from putting it in a zip file and writing a password on it.
Okay. Anybody else? That sounds like where we're going. So anybody else have a view on that one? Okay, if not, we'll take that as the proposed consensus. Okay, thank you.
I'm sorry, I was checking on the notes to make sure we're capturing that.
Yeah, I don't see anybody else on the queue.
Appreciate the note takers.
All right, thank you, Russ and Brennan. Next. All right, that's the end of my discussion of suit, although suit does come up on one later slide. So if you're from suit, don't leave the room, which has to do with the relationship between suit and rats and TEEP. So now we're getting into the details of attestation and the relationship to EAT tokens and the rats working group. So, and I think this is the longest section of slides, so you'll have to track my time and tell me how I'm doing. So, okay. EAT tokens. Okay, we just had a discussion about suit reports can contain sensitive information. By the way, EAT tokens can contain sensitive information. What draft 11 said is it should use encryption as discussed in EAT, okay, as opposed to some other type of encryption, right? The problem is the EAT profile section in draft 11 has a bug in it where it says under COSE and HOSE protection, in this case just COSE protection, that's the field name out of the EAT specification. It says you got to have a field that says this. We only use COSE. It says see the cipher suite section. The problem is the cipher suite section is the one for TEEP messages, and TEEP messages are not encrypted. And so right now you can't follow that should. The C cipher suite actually is false because this would tell you don't do encryption, you got to do encryption, right? So that's the bug. Okay. And so the question is, when you're sending an EAT token that has sensitive information, and you should use encryption as discussed in EAT, then what cipher suite should you use? Okay. And for example, do you sign and then encrypt EAT? Do you encrypt it and then sign? Probably sign and then encrypt. But which cipher suite for encryption do we specify in the EAT profile? Okay, because we don't specify it for the TEEP message, we specify it for the EAT profile. We got to specify something there. And so this is where I mentioned suit here is you could make an argument that a good cipher suite to use is the one that you're already implementing for your suit reports if you care about sensitive information in both EAT and suit reports. Okay, it sure would be nice to have these same things that are mandatory to implement in constrained devices. Okay, so there's a good argument there. A possible argument on the other side is that the destination of the suit report and the destination of the EAT are different entities who might have different requirements, right? One goes to a verifier, and one might go to the TAM who might be processing the suit report. And so maybe there's cases we want them to be different, but I guess right now my preference would be to recommend them be the same and leave it to extensions to if you ever had a case you want it to be different. And if they're the same, that means that we still need to pick something, okay? If you go back to the discussion that Brendan and Russ and I were just having, whatever the encryption mechanism is for suit reports is something that the suit report itself document would not say. We do that in the EAT profile. And we would also say the same thing in for suit reports as well as the EATs themselves, because the point that I made the suit working group is it's not just the suit report and the EAT. There's a bunch of other claims in the EAT that's not, right? And so we'd want some generic statement, some generic algorithm in crypto. So far, we've only talked about in this working group signature algorithms. We've talked about EDDSA and ES256. We've not talked about the crypto algorithms, or sorry, the encryption algorithms. And so I guess I would like maybe Brendan's opinion, since Brendan had the mandatory to implement document and suit for constrained devices. Should we just take the cipher suites or some portion of the cipher suites there as the default one for this working group in the EAT profile? Or is there any reason to use different ones than what you put into the, and again, we're talking about the encryption algorithms in the MTI document and suit.
I gather that some of the implementers already have a hard requirement in TEEP for using RSA in signature use cases. That being the case, I would be inclined to ask them what they require, because those are not in the suit MTI draft.
Okay. Anybody here have an opinion? Otherwise, we'll ask the question on the list. Anybody here have an opinion on encryption algorithms for use in encrypting suit reports and or EAT tokens? If not, we'll just ask it on the list.
Sorry, Brendan Moran back at the mic. Maybe I misunderstood the question. This isn't about key exchange at all, is it? You're just talking about the symmetric encryption. Okay, my apologies. Right. There's been a massive discussion going on this. And given the kind of environment that you're in, it strikes me that you do not need to deal with out of order arrival of data, correct? You do not need to deal with a situation where you haven't got enough space to store the ciphertext instead of the plain text, correct?
Because here it's the sender that's the one that's likely to be constrained, not the receiver.
So this should not be an issue for you. And on that basis, I wouldn't try to use any of the constrained stuff. You probably want to use one of the AEADs, just because it provides less room for error.
Yeah, there might be requirements that says the encryptor side needs to be as small as possible in terms of the implementation and space and so on, but the decryption side is probably unconstrained.
Yeah, so if you can afford AES GCM or AES CCM, then that's the direction you want to go.
Okay, thank you for the recommendation. All right. +1, okay, +2, the Hannes also thumbs up, okay. Next slide. Okay. Thomas Fossati raised this one. In draft 11, it said that in the EAT profile, all claims were listed as optional, and he observed that that's probably wrong. And so there's an open pull request here, ready to be merged if there's consensus, that has this, 1, 2, 3, those 5. So there was 6 claims already talked about in the document, okay? And these match to what the architecture document says that TAM would need to know in order to do remediation, right? And so those are the 5, and then the 5th one is just for freshness. So the 5 ones, it's actually information that they need to make a decision as to what binaries are appropriate on the device and whether they're up to date and so on, is those 5, right? A unique identifier of the device, unique identifier of the OEM or hardware vendor, what the model, the version is, and the manifests that are already installed in the device. That's the list. Okay. So the proposal is to take all 5 of them and then make those be mandatory instead of optional. Okay. And then the 6th one is the nonce, and that one would be mandatory if you're using the nonce freshness scheme. And if you're using the timestamp freshness scheme, then the timestamp is mandatory instead. Okay. And so that's the proposed resolution to that one. So I think the only way to implement a TAM is to have all the information. So, okay. So there's comments. Next slide. Okay. So the EAT spec says this. So this is one that we talked about at the hackathon, and we talked about it between the suit rats and TEEP people that were at the tables and things. The EAT spec says a suit manifest can be used as a manifest. And then the EAT spec has fields there for a content type, which is a COAP content format, and then the body, which is in this case like a JSON or CBOR blob. And so he says, well, exactly how do I put a suit manifest in there? Okay. If I'm going to use CBOR, which CBOR production is it? Okay. Is it a suit envelope, or is it a suit reference, or what? And so between Brendan and me and I think Lawrence, we said, well, the proposal is to say what you put in here is a suit reference. Okay. You know, it's the ID and the URL from where you can get it and so on, but not the whole thing, right? And so that means that someplace we would need to write this down and get a COAP content format for the suit reference. Okay, so that is the proposal, is to get a new value allocated for COAP content format that means it's specifically a suit reference object, and then write down, and where would we write that down? Probably in draft IETF suit reports, which is what defines the suit reference CDDL. Okay, I saw a couple nods, so okay. So that means that's work for Brendan that I would, in the suit reports document that we will then reference in this document. So he's shaking. No, not again. Okay, next. Okay, we did update. This goes back to the spec. Used to have a very old sample EAT token that needed to be updated with the latest claims and stuff as they appear in EAT, and so this has been updated now. And so this fills in what we just talked about here. And of course, since there isn't a COAP content format yet, it temporarily has 60, which is application/CBOR, with a to be replaced to do this as soon as we get a value, change the 60 to be whatever the new one is, right? But it means you could actually code this right now and use it in the meantime in hackathon tests and stuff. And you can see here's an example suit manifest, which has a sample URI and the digest and so on. And so this is just in the pull request, which unless there's any objections, we'll merge the pull request, and that'll be what's in dash 12. Yeah. Next. Okay. This is the intro to the next one. This is not the open issue, but as a reminder, way back when in 105, we talked about how you could use this in the following orientation, where the TAM is kind of in the middle, where when a tester wants to get attestation results that can present to some other relying party, they do so by sending it through the TAM as if the TAM was a verifier. So it's like you have chained verifiers in each case. So you send it to who you think is the verifier, which is actually the TAM. The TAM sends it on to another verifier, gets back the attestation result. If it's a failure, the TAM kicks off remediation and starts doing updates as necessary. If it's a success in their hand, it passes it back to the tester, which can then present it. Okay, so that's the example flow here, the example composition. You don't have to do it this way, but this would be one way that might be popular. Okay, and so way back in an earlier IETF, we said, so what message is it that passes the attestation result downward from the TAM to the TEE? And in IETF114, we said that was the TEEP update message, where we had updated it just before 114 to have that as the answer. Okay, so that's the you got to understand this to understand the next slide. Okay, so now we got the context. Next slide. Okay. So the discussion we had at the hackathon is out of the TEEP profile, or the EAT profiles for attestation results, okay, there's two profiles that have been defined so far. One is the one that's the TEEP profile in the TEEP document that's for use by consumption by the TAM, okay, and EAT that's going to be, each attestation results is going to be consumed by the TAM. The other one is AR4SI is the acronym for the draft in the RATS working group, and that one is designed for other relying parties, which was that other box in the slide. So the attestation results line that comes down, there's one profile for the thing that comes to the TAM and a different profile for the things that comes to their relying parties. So what's the relationship between those two things? Okay, this is what we had the discussion at the hackathon about. And it turned out that those two things could even be encoded differently, because EAT say both JSON and CBOR, whichever one that you want. And so it could be that the TAM requires it in CBOR and the other relying party requires it in JSON. So that means, and similar, your freshness mechanisms might be different. One might be using timestamps for freshness, the other one only supports nonces for freshness. Okay, so it means you might have disjoint requirements here. And so does that mean that you need to like encapsulate them, and you need a media type for all the combinations of A and B and things? And so that just seemed problematic. And so there was 5 options we discussed. The first 3 of them have all those above issues. And so we kind of decided maybe that's not the right way to go, even though that's kind of what the draft previously would have implied. But we didn't like any of those first 3. Actually, there's downsides to all 5 of these, and that's why there's not a proposal on here. I might have my own preference on here. So option number 4 is to say, this one actually requires, since we don't say anything about the protocol between the TAM and the verifier, okay? And neither does RATS, by the way, right? You can use whatever protocol that you want. It just has, so here's some message formats, but you got to put them in some protocol. You know, could be HTTP REST API or whatever. This one does have option 4 has a constraint on that protocol, which says, when I'm going to send off the evidence and I'm going to say, hey, please give me attestation results in the form of, CBOR, or give me it in, here's the profile. I want the TEEP profile or whatever, is in option number 4, in that request, you'd say, I need it back in 2 different formats, please. Give me 2 blobs, okay? Not just one, okay? So I can't just do it like a regular accept header, right? Prior to constraining the protocol. I need it in this one and in this one request, 2 blobs in the response, okay? That's what number 4 is. And then I can get it back. One is opaque to the TAM and you can just pass it on, and one is consumed by the TAM, okay? And so that one is like having 2 parallel accept headers and 2 separate responses, one that you parse and one that you just pass on. That one's kind of weird, but you could do it, and it's fewest number of messages maybe. But it does work with all of the different previous constraints. Option number 5 is to say, well, this flow that puts the TAM in the middle, well, just don't do that. Instead, make the attester go all the way around to get the AR4SI. So this line that comes here, AR4SI, would not actually come through the TAM, nor would the evidence. The evidence would come to the TAM, and a separate evidence would come to the verifier, and each of them would respond separately. Okay, meaning evidence comes to the TAM, this one comes back here, other evidence comes all the way around to the verifier and comes all the way around back to the attester or the other relying party, depending on whether we're talking about background check or passport model. Okay, so that one means double the messages from the attester or the other relying party. I say or because it depends on background check versus passport model. Both cases are there, but they collapse into this. And so if that was a constrained device, that means, hey, 2 messages, perhaps more power consumed and so on. So that's the disadvantage of number 5 is a little bit more complexity because you can't hide all the complexity behind a TAM if you have a tiny constrained device. Okay. So those are the 5 things that we know of right now. Anybody have an opinion on which, if there's some of those they would like to vote off of the island or they think would be the most appropriate for their favorite use case? Okay. Otherwise, since number 4 actually constrains the protocol, somewhere between 4 and 5 is my preference, unless somebody has another magic idea. I would prefer to not try to do the media type parameters allowing each combination, which all 3 of 1, 2, and 3 would have that problem. So we kind of scratched our head during the hackathon and said, we'll bring it up here, see if anybody has any magic advice for us. So otherwise, the authors will try to figure out what to do in the next version of the draft. So
Okay, Pegling, you're in the queue.
Me?
This one is the hardest issue. So if I get cut off on time or whatever, this is the one that I really wanted feedback on. So
You got 5 minutes.
okay, cool.
Hello, can you hear me?
Yep. I'm going to step out here where I can see you, though.
I wonder if it's possible that the time is the verifier.
There can be a case where you take the TAM role and the verifier role and you collapse them into the same node. Yes, that is possible. And then option number 4 becomes much easier in that case, right? Because there's no protocol between those. It's your internal implementation.
Yeah, because I think if we use TAM as a verifier, and this model will be more simple to use, I think.
We never want to force people to use the same TAM and verifier combined, but allow it, yes. Force it, no. And there are people doing verifiers that want verifier implementations to be usable with many different relying parties, including a TAM, for that matter. I think Verizon was one of the implementations. That's Thomas Fasades and folks that was there at the hackathon that's doing exactly that. And so we had some people at the table that had the TAM implementation, some people at the table that had a verifier implementation, and we wanted them to be able to interoperate without precluding the fact that you could combine them into the same implementation.
Okay, thank you.
Akira? Yeah, Hannes. No. You okay.
Yeah, between the option 4 and 5, probably I will prefer 4 just because it's more easier to revise the current draft. Mm-hmm. But not the technical view. But I have another question with the question I had in my hackathon is what is by reading the current draft, what is how to implement with the other than like SGX or TDX or something. It's really need to ask somebody who really knows the implementation or the history of the draft. Mm-hmm. So each profile explanation, probably we need to make it more informative in the draft.
Yeah, I was actually wondering whether we need to cover both the background check and the passport model together. Like it would be possible to just stick with one, specifically if this one is more exotic, or is like nobody's forcing us to cover the whole topological flows from the RUTS architecture.
So here, so far, the working group has been concentrating what's shown here with the TAM, and then same in the previous slide, right, is that the TAM is acting in the background check mode, right? In other words, it's not the attester that talked to the verifier. The TAM is a specific relying party for mediation. And so this is a background check picture here. But you saw in Akira's hackathon report that one of the implementations was trying to do Passport with this. So we actually do have our first implementation that's using not this picture, right? It's using something that's much closer to option 5. Okay, and Akira's nodding here. The other implementation is using option 5 because it's using Passport, right? So this issue here of the relationship tends to be more complicated in the background check model, which is actually more common, but not necessarily ubiquitous, right? So I think my opinion is, especially after hearing the hackathon stuff, since we had both Passport and background check implementations at the table in the hackathon, is we probably need to accommodate both, was my takeaway. So before this hackathon, I might have said, let's just use background check for the TAM. But now that we have an implementation, I'm now kind of convinced that that's not necessarily what everybody's going to do. So the last thing that I will mention here is this bullet right here, before we run out of time, is that that TAM could, in theory, send 2 different queries off to the verifier, right? If it just uses like a REST API with an accept headers and stuff, it could send the evidence twice, okay? But the only problem there is if it's using the nonce mechanism, it would need 2 different nonces or the ability for the verifier, the receiver, to accept the same nonce twice, right? And so it tends to have problems in the nonce mechanism. If you were using the timestamp freshness mechanism here, you could actually do that just fine. Okay, so, all right. If I still have time, I'll do another slide. So,
Well, that was it.
that was the last slide? No, I got okay. The last one, this one is done in draft 11, so just want to confirm this is fine. I think I forget who raised this one. The EAT profile is when we talked about before that content format, and we said how it looked if it was an SGX code or whatever, and there's the value that Akira showed that said it was an EAT profile EAT, and say, well, that was kind of a long string. And so what happens if in the future you rev that, okay? Because what it says right now is if your value you're going to send is equal to that string, you can elide and omit leaving that long string because the absence implies it's that string. So the question was, well, as soon as you rev it, doesn't that mean that you've lost encryption and the encryption is not going to, not encryption, compression? You're going to need that to be in all future messages anyway, so why bother with the elision now, right? And so I think it was Michael Richardson asked this. And so what it says now is it says, well, whatever the absence means is defined by the TEEP protocol version, which is a single integer elsewhere on the same header. Okay. And so if you ever wanted to rev it, then you can easily bump this TEEP protocol version, which then specifies a different default. So every time you can get a new default, and you can always, omit the thing as long as you're sending the exact thing that that version says. Okay. So it provides a mechanism to rev that's already in the spec, which is the version number identifier. And you say, well, if we had TEEP version 2 or the TEEP version, a TEEP extension or whatever, would you say we'll put the value 2 in there instead of the value 1, and then it has a different number in it, and you can easily do that. And so you can always get the, and he said ACK on that being done. So it's just reporting that out. Okay. All right.
2 minutes over.
All right. I think that's my last slide, right?
Yep.
Yeah, so I got through all my issues. Well, all right. Okay. So I think Penguin is up next.
Hello, this is a very brief presentation of the TEEP use case for computational computing network. Next slide, please. There are some issues I collect from last meeting, and I also upload in the TEEP GitHub. So the first issue is a cloud scenario should be included. And the response is that we change the abstract, and this and the text is the document is a use case and extension of TEEP, and could provide guidance for cloud computing, MEC, and other scenarios to use computational computing in network. So next slide, please. Yeah, here's the second issue. It's the security of computational container should be clarified. And since the CCC computational computing consortium have defined that the computational container, so I will follow the terminology definition. And here's the example: if a SEVSN PCPU maintains a container in a virtual machine, then this is a computational VM rather than a computational container. So here is the fix. Next slide, please. This is the specify or refer to secure channel in other document. I think I haven't found a definition of secure channel in IETF. Maybe use the using attestation in transport layer and the data transport layer security draft as a secure channel. Maybe I can use a loosen definition. For example, some transformation from some transformation method that could protect the data in transfer. Maybe this haven't been determined, and I think I will fix it in next edition. So next slide, please. The fourth issue is the typo and the format correction, and I think I have fixed all the typos. Next slide, please. This is a provisions type in 4.1 where UATA and PD are bundled as a package, and the comment is that the network user could use transfer encrypt package before attestation for efficiency. And as a response, we delete the encryption package and the decryption key, because if we already have a secure channel, then there's no need to encrypt the package. And I also changed the draft as that in the below. Step 3 is the time request remote attestation to the TEEP agent, and the TEEP agent then sends evidence time. Here's the point: the time works as verifier in REST architecture, and according to the conversation just before, if we don't force people to use the time as a verifier, maybe I need to lose these steps another type. So yeah, maybe I need to loosen these steps and try to provide just guidance, not enforce people to use this network management and orchestration center as the verifier. So next slide, please. And here's the provisions type 4.2 where PD is a separate package and the TA and the UA are separate or integrated. The comments here is that clarify, deploy, and load in this case. So in the step 3, the network user will transfer UA and TA to the confidential computing device via a time zone, deploy these two applications in RE and T respectively. And in SDX, the UA must be deployed first, then let the UA to load the TA in the SDX. So next slide, please. Here's issue 7. Here's the comment here is time is not in the path of UA distribution. So we just fix the step as the network user deploys UA in RE and how it deploys. I think it's out of scope of this document. So next slide, please. Yeah, here is the introduction improvement. I think it's I try to solve this issue by using multi-party computing and federated machine learning to explain these use cases, because both MEC and federated machine learning will use TE as a method to protect their private data. I'm not sure if I should add this text in the main body text or in the appendix, and I think I will fix it in next version. Next slide, please. Here is the specified data owner, and in the document, the data owner has been replaced by the network user, because network user possesses the personalization data and applications that need to be deployed on confidential computing force. So next slide, please. Yeah, here's the loosen deployment options. I think it related to the issue 5, 6, and 7. And next slide, please. And here is one question that the UA may be tempered, and this may cause DOS attack or even DDoS attack. And I think that the UA is defined as untrusted, so the TEEP architecture cannot make sure that the UA is secure and the trustworthiness. So in some meaning, I think that the DOS attack cannot be totally denied. But if we could create a secure channel between the TE and the network user all the time, for example, if we use codes to encode the network data, the server side of the TE could discard this malicious network flow as to T-broker. Since the T-broker is transparent forwarding and is also not trusted, so the network flow filter may be not reliable to block malicious traffic by the T-broker. So next slide, please. Yeah, and the scope of the document. I think the scope of the document should not only include edge computing scenario. The scope could be any confidential computing environment which need to be configured by network. I think that's the report. Yes. Yes.
Okay, so all these were updated in the last revision, Peng-Ling?
Yes, yes.
Okay, so let's continue to review.
Okay.
Oh, Mohammed, you're in the queue? So
Yeah,
I'm going to
so
have to
do
keep
you,
the queue because we're at time. Go ahead, Mohammed.
yeah, so do you hear me?
Yeah, I can hear you.
Okay, so in one of the issues you mentioned a definition that you used from CCC, Confidential Computing Consortium, and we
Yes.
had analyzed some of their definitions and there is no scientific evidence for any of the definitions. Somebody has just put them around and there is no scientific kind of justification for these. And I wonder, why do you pick up these? And so CCC is not a standardization body, I mean.
Because I think there's no standard definition about confidential container, and from my perspective, in my opinion, I think that a container is confidential. It must be totally confidential. It cannot be in a virtual machine. That as we say, the virtual machine is confidential, so the container is confidential. If we say a container is confidential, then only the container is confidential. Any components out of the container don't have to be trusted. That's my personal opinion, and I think this is a reasonable explanation of this confidential container definition.
Yeah, I mean, that's fine that if you have your own perception, but having CCC does not justify anything, because I will put a link in the chat. So we analyzed some of their definitions and there was no justification whatsoever for them. So if you have your personal opinion, that's fine. But the point was that having CCC definition or as a reference does not justify anything.
Hey guys, let's take it on the list. Yeah, this is a good discussion, but let's continue on the list.
Okay.
Yeah, Mohammed, can you post the link and information that you were speaking on the list?
Yes, sure. So I will put it in the, so should I put it in the list or in the chat?
List, please.
Okay, sure. I will send it in the list. Thanks.
Okay.
Thank you,
Thank you.
Mohammed. Yeah. Thanks everyone for the session, and I think we're making good progress. So hopefully we will see the TEEP protocol draft advance very soon. And we are hoping we will initiate early SEC Directorate and IoT Directorate reviews on the TEEP protocol.
So, Dave, once you have an updated protocol, the question will be, are we ready to do early reviews to get working with Pascal? So we can take that up on the list. Akira. Protocol specification, once you get the next revision, do you feel that it's mature enough that we can trigger an early review? Well, you don't have to answer now, but you know, it's something that we can take up on the list.
Like the informal pool of implementers throughout the yes.
Okay, let's take it offline and
We'll confirm that
yeah.
on the list.
Yeah.
Thank you, everyone.
Other than me, most implementers
Hi, Nancy, Tiro.
Bye, thanks, Ming.
Bye, Ming.
Yeah, bye next time.